So to find the limit at a partition, basically take a look at this. We've got the limit as x approaches 3. And we've got one function here, x is less than or equal to 3. Another one for x is greater than 3. Basically, what you have to do is this. You have to find the limit of f of x as x approaches 3 from the negative side. And you have to find the limit of f of x as x approaches 3 from the positive side. So as x approaches 3 from the negative side, it's, the side of values that are less than or equal to 3. So basically what you do is you take 3 and you plug it into the function that's to the left of 3. That gives you 13, right? So 2 times 3 plus 7, that gives you 13. For the limit as x approaches 3 from the positive side, you take 3 and you plug it into the function to the right. In that case, that gives you 3 squared minus 1 is equal to 8. And yeah, when we're taking limits, we never really look at the actual values. However, this is a pretty good approximation, right? Because technically we're looking at what is the y value approaching as x is, let's say, like 2.99999, and 13 is a pretty good approximation. And then 3.00001, 8 is a pretty good approximation. Because these two are not equal to each other, we say, therefore, the limit of f of x as x approaches 3 is equal to dne, right? It does not exist. Right, so if we take a look at this next one, we have the limit of f of x as x approaches -1 from the minus side, and the limit of f of x as x approaches to -1 from the positive side. Okay, this notation is okay. We're gonna go into like even better notation, right? So you have to show this, and let's, like, if we mentally plug in -1 into the top function, we get 1 plus 2 is 3. And then if we plug in -1 into here, we get 3 as well. So how do you write the statement here? You say, since limit of f of x as x approaches -1 from the minus side equals the limit of f of x as x approaches -1 from the positive side, right? Then the limit of f of x as x approaches -1 is also 3. Okay? Okay. Here, the reasoning for the first one would have been, right? It would have been because the limit of f of x as x approaches 3 from the negative side does not equal the limit of f of x as x approaches 3 from the positive side. So again, in math, the higher up you go, it's not about the answer. It's not about, the limit does not exist. No. Then there is another part, and you're usually going to be asked, okay, justify your answer, or why. And when it says to justify your answer, or why, this is the part where you justify your answer. This and this. And there's like very strict notation of how you want to write all that. Okay? Yeah. Yeah. Okay. So take a look at this problem. The width in millimeters of an animal's pupil is given by this, where x is the illuminance of light shining in the pupils, and it's measured in LUX. Yeah.
Does using the word sensor because matter for that, or are those interchangeable?
I mean, no, it's fine. Okay, so how, like, when the room is dark, your pupils will dilate in order to take in more light, and then when the room gets so bright, right, your pupils will contract in order to not bring in more light, because then, like, that will, burn the rods or whatever. Okay, all right, so put away your calculators for a minute. Let's take a look at this. So it says to write a limit to describe the width of the animal's pupil, and remember the width is d of x, right? When the light is at its minimum. Okay, so what is the light here in the problem? X is the luminance of the light shining in the pupils, right? So when the light is at its minimum, this is telling you the limit of d of x as x approaches 0. Okay? So the light is at a minimum. It means you have as small amount of light as possible. Then find the limit and interpret your results. Okay, so the limit that we want, okay, is this. The limit as x approaches 0, and this is the function. And I've purposely chosen a function that's kind of like nasty looking, because you know what? Sometimes we just have to learn how to deal with that stuff.
Wouldn't it just be 85 over 10?
No, hang on. Plus 10. Okay. So we want x to be 0, right? So take a look at this for a minute. We have a negative exponent for the x, which means it kind of takes things to a different level, right? Let me write that over again. This is the limit as x approaches 0. And if you write this in like standard form, this is what it looks like, right? Okay, so if you have 152x to the negative 0.45, this is 152 over x to the 0.45. And so now as x approaches 0, this is going to be like something close to 0 to the power of 0.45, which is about 0. So now I have a number divided by a very, very small number. And remember, let's just focus on this 152 over x to the 0.45. Just in that fraction, as x becomes very, very small, the fraction itself will become what? Infinitely large. So it'll be like, we never write this, so it'll be like infinity plus 85, and then an infinitely large number plus 10. Can I even like work with that? Can I cancel out the infinities and say it's 1? No, because like, okay, no. So what I have to do then is use algebra, just like we did on the homework. Use some algebra in order to simplify this function a little bit more, right? So why don't I, you know how like in the top, the denominator is x to the 0.45, and here as well, I can multiply top and bottom by x to the power of 0.45, right? Do you guys, right?
Once we do that, do we stop writing the limit?
No. We have to keep writing the limit. So now if I distribute this to the first and second piece, I get 152 plus 85 x to the 0.45, and then 4 plus 10x to the 0.45. Okay?
Is that as simple as it
Is it?
No.
Well, okay, so now what are we going to do? Now, well, yes, this is as simple as this goes. So now, am I allowed to plug in x equals 0? Is it okay to plug in x equals 0 now? It is. If I plug in 0 here, what do I get? That's basically just 0, right? And this is 0, so I'm just going to get 152 over 4, which is equal to how much? 38. Okay? So, that's fine. And here it says find the limit and interpret your results. So what this is as x approaches 0, x is the amount of light. As the amount of light approaches 0, d, which is the diameter for the pupil, is approaching 38 millimeters. So now you have to write that as an actual sentence, right? So you say, you know, when the light is at its minimum, you can even say, you know, when there is about, you know, 0 LUX of light, right? the pupils have a diameter of 38 millimeters. Or you could say like the pupils will approach a diameter of that, right? Because it's approaching. Okay, River, question?
Why can't we plug in 0 right away?
Because x is not 0, x is approaching 0. And as x is approaching 0, if it's at the denominator, then this fraction will be infinitely large. So now what do you do with that number? An infinitely large number that you don't know what the value is, plus 85, and then another infinitely large number, plus 10. Well, how do you divide those two? You can't make sense out of that.
Okay.
Right? Yeah. Sure. Other questions? Okay. Next, write a limit to describe the width of the animal's pupil as the light is at its maximum. Now, x is going to approach infinity. So, look up here before you write anything. We're going to start with this function, right? Which basically this and this are identical, right? The first two steps are identical. So now this bottom number is going to be infinitely large, right? Which, so what you can actually do, right, is you can start at, because all of these steps are equivalent fractions, you can actually start at a fraction that suits your interest. So I'm actually just going to start with this last step, right? Because once I simplified everything, why don't I just use the one that works better for me? So the limit as x approaches infinity of this function over this function. Now this is a different situation. Now when I have a limit as x approaches infinity of a rational function, all I have to do is take the leading term from the top and the bottom. So this is the limit as x approaches infinity, 85x to the 0.45 over this. This step is extra. You don't need to write this step. I'm just showing you so you can visualize what happens. So the variables cancel and you basically have what left? 85 over 10, which is 8.5. Okay? So as the light approaches maximum illuminescence, the pupils will approach a diameter of 8.5 millimeters. And here, you can use like other verbs, right? So for example, you can say like, the pupils will, shrink to a width of 8.5 millimeters because that's what it's doing, right? So like a little bit of the wording is like, you can change that. However, like, maximum illuminescence, a diameter or a width of 8.5 millimeters, the units and stuff, like those are things that need to be there. Okay, questions? Yeah.
Do you only take the leading term?
I said again.
Do you only take the leading term of like
The
thing
top and bottom.
when it's x is going to infinity?
Okay. All right. So this next one. Okay. Again. So math is something that applies to like different forms of life, right? And so I'm really trying as much as possible to put in problems like from, that you don't really have like expertise in, but you can like get through the words and, solve what is being asked of you. So in molecular theory, the root mean square speed measures the average speed of particles in a gas, defined by this formula, where R is the gas constant, T is temperature, and M is the molar mass of the gas particles in kilograms per mole. Great. Yeah. Perfect. Now, find the limit of V as M approaches 0. Okay. So, have you guys seen that formula? No. Not in AP Chem? Is anybody in AP Chem?
Yeah.
Okay, so this is what we want. So this is what we want. This is the limit as m approaches 0 of this cute little thing. Okay, and you know what? Who cares what any of these things are? I know that r is a constant, t is some whatever quantity, m is the mass. Now I want to see what happens to this as m approaches 0. Well, m is in the denominator. As the denominator of something approaches 0, what happens to the entire fraction? Approaches infinity. And what's the square root of infinity? Still infinity, if you can believe it, because infinity, like, it's such a huge number, right? So this is just going to be infinity. That's it. There is not much work here, right? But it's so important that you can, sort of like wrap that around your, like wrap your head around all this.
You have to put the in here though.
You don't have to, like, it becomes like infinity or infinitely large. Okay. Okay, so interpret your answer. So what would you say?
As the mass,
Uh-huh.
approaches 0,
Right, and what is v?
Speed.
The speed, right? The average speed.
speed increases.
Right. So as the mass,
We are supposed to write this for B or
no, A, as the mass of the particles approaches 0, the speed, or the average speed, becomes, okay, one way to say it is it becomes infinitely large.
you say that the speed increases.
Huh?
You can say the speed increases
You
infinitely.
can say the speed increases infinitely. Okay. All right. So here, what about this one? So the limit as m approaches infinity of this thing. Oops, m. So what happens as the denominator approaches infinitely, or approaches infinity? Or to 0. And that makes sense, right? Like if this mass becomes like infinitely large, you can just, it's gonna be so heavy, right? So, and then here you would just say like the opposite. As the mass of the particles gets infinitely large, the average speed will approach 0. Okay? I'm gonna ask you guys to write stuff in English on the quizzes and the tests in coherent English sentences. Okay? Yes, your worlds are colliding at an average speed of this. Okay. Okay, I know.
What do we write for B? You said as the
You tell me, what do you write for B?
as the mass of the particles approaches infinity, the average speed becomes infinity, or just becomes smaller, or
It becomes the average speed approaches what?
0.
0, right? Okay. Remember sequences, which you all loved?
I loved it so much.
Right? Remember A sub n, which was like, the explicit formula of a function of a sequence? You guys remember that? Okay. So, you remember how we talked about converging and diverging? Yes? So, what did we have? We had A sub n, and you would find, you would say, for example, n equals 1, n equals 2, n equals, I don't know if this goes with this, n equals 4. It doesn't, okay? This is not the graph for this function, clearly, okay? And then you said, okay, so here, 1, 2, 3, 4, 5. When n equals 5, this particular A sub n is, I don't know, 124, okay? And then when n equals 6, it's, 256 or whatever. So now, as n approaches infinity, how much is the specific value? Another way to write that is by finding its limit. Okay, so I've said write the first 5 terms here, but I think we're all comfortable with doing that. Let's just move on to finding the limit. When it says find its limit, Code word, this is find the limit of a sub n as x approaches infinity. Because who cares about the limit as x approaches 1? We can find that already, okay? So here's what we're going to do. The limit as x approaches infinity of a sub n equals the limit as x approaches infinity 4 over n squared plus 1. Okay, there is no work to show here. Obviously, it's a non-calculator portion, right? So you just have to reason it out. Consistent notation. Hang on, what am I doing here? These are supposed to be n's. They're all n's, no x's. Okay, please. Okay, so when n gets infinitely large, well, n squared is even larger. Plus 1, it's even larger. 4 over that large number is what? Really small or 0. So this is just going to be 0. Now, if this is a 4-point problem and I catch somebody having written this, okay, infinity squared plus 1, if this is a 4-point problem, I'm going to take off 5 or 6 points. You're laughing. I'm not. Because, okay? And your grade will then approach 0!
Maybe real life applications of math.
There you go. Yep.
We have to write the whole limit of
Yep.
Oh, okay, so we can't just
Yeah.
do
Okay, here. Let's find the limit as n approaches infinity of b of n. So look, write this, and then you don't have to write the next part because it's such a long function. But take a look. This is a limit as n approaches infinity. So what do? We take the highest degree from the top, highest degree from the bottom. Okay, from the bottom it's easy. Remember, you take the highest degree after everything has been multiplied out. So when we multiply all this out, in the bottom we have 6n cubed. Do you guys agree with me?
I do.
So we're just going to write this. We're just going to shortcut this. We could only do this because it's limit as n approaches infinity. Otherwise, you can't pick and choose terms. Now, from the top, if I multiply all this out, I'm going to get a 9 times an n times an n times a 2n. Right? This is just like the first terms of everything. So it'll be 18n cubed. And how much is that? 3. Okay? Oh, and by the way, what this is telling me is, if I were to continue like graphing all of these points, eventually, as n approaches infinity, my values are going to approach 0. So would that converge or diverge? Converge. And what about this one? Eventually they're going to approach 3, also converge. So both of these converge.
When it diverges, it just means that like.
When it diverges, hang on. So both of these, like this is going to go up to 3, and this is going to go down to 0. So when it diverges, remember, it either goes to infinity or it'll be like DNE somehow. Okay? Yep.
Can you explain again why we're not multiplying
Because we only take the first term, the highest,
why
the term with the highest degree, because this is the limit as n approaches infinity. And just like if you have, like a function like this, when n approaches infinity, just take the term with the highest exponent, because like if you've got something to the power of 5, infinity to the power of 5 compared with just infinity, infinity to the power of 5 wins. So you ignore everything else. Okay, this is where we stop.